Okay, our next presentation is called Web Consistency Testing. It's a tradition at GTAC to have a token founder. All right, we don't care what they found, just a founder of something. Because just in case, you know, they ever make it just ultra wealth, we're like, hey, man, remember that GTAC invitation way back when? And if they fail, we can ignore them and act like it was just a big mistake. So Kevin Menard is the founder of Mogo Test. So he is our founder. And he's done a lot of work in Apache and open source Cayenne and Tapestry projects, Selenium, and the Rubber Capistrano plugin. We're gonna have to talk about that one over a beer. Kevin Menard.
All right. Hi. I'm going to talk today about web consistency testing. Don't worry if you've never heard of it before. I kind of pulled an old consultant trick and just completely made up a term. Web consistency testing is a new entry into automated web testing. In order to best describe what it does, it helps to frame the context for this a little bit more. So web testing is a pretty diverse space, but automated web testing basically falls into one of three categories. You have your back-end testing, typically unit testing your data models, functional testing, your URL endpoints that modify that data. You have front-end, and this usually manifests itself as validating either your HTML or CSS. And more recently, we've been seeing some automated testing of JavaScript. And then we have end-to-end integration testing. Again, this tends to be a two-pronged approach. We're seeing a lot of collaboration between browser automation tools and the browser vendors. As great as that is, things are getting much more stable, much faster. They're still very terse tools, so it helps to have something layer on top of that. And we've seen Capybara and Cucumber and a few others try to help develop these acceptance tests. All right, so this is your typical automated testing diagram. I felt kind of silly putting this together, but it was more rhetorical than informative. Notably absent from all this is the user. So we're really good at testing how a browser interacts with a server, how a server interacts with a database or other services. The end-to-end integration testing on the workflow side kind of models what a user will do, and we can handle things like a user clicking a button. But the primary way a user interacts with a site, at least initially, is viewing it. Websites are primarily a visual medium. And I apologize for those that are visually impaired, but my understanding is accessibility testing really isn't considerably better. We care a lot about how a page looks. This is why we spend so much time on design. If we didn't, we'd just adopt the tersest set of widgets we could to perform whatever functionality we need to. But no, we do care about design. It defines the site. It enforces company branding. And to ignore how a user views a site is kind of a big problem. Put another way, it's great if you can test that clicking a button triggers an event handler, which fires off an AJAX request to the server, which parses the request, interacts with the database, generates a JSON response, kicks that back over to the server, it catches it in its success handler and modifies the DOM. But if you never see the button, then it'll never get clicked. Or maybe it's partially occluded, or maybe the page just looks like crap, and as a result, the user just moves on. So what we're really talking about is how to test that a page conforms to a design. And there's a ton of different ways that this whole process falls apart. I jotted off a quick list here, but I'm sure we've all run into a case where a page just doesn't look the way we expect. Sometimes a developer just doesn't care. Maybe they decided they don't want to work in a particular browser. Sometimes it's a lack of skill. Sometimes a designer just hands over a design that doesn't work. A lot of print guys coming over to web are really guilty of doing this. We've all dealt with looming deadlines, and as a result, we cut corners. And then some of the more nefarious ones are the web specifications are ambiguous in some cases, and we've all experienced how the browser vendors handle that situation very poorly. We have browser vendor extensions. Anyone who's tried to round a corner in the last 3 years has probably found 75 different ways of doing that. Gradients fall into that as well. And then some of the other stuff is the page actually works, conforms to the design, but there's dynamic content. Or we introduced a new translation, and now your beautifully designed page that worked great in English falls apart in German or Swedish. Maybe the design only called for about 2 paragraphs of text, but it's backed by a CMS. A copywriter comes in, adds a 3rd paragraph, and everything falls apart. Unfortunately, the testing of this falls on a spectrum kind of between a rock and a hard place. On one hand, you just do no testing whatsoever and just ship things. And for a lot of smaller companies, this is what they do. Or they decide they're not going to support 20% of the browser traffic because it's just too difficult. Then they'll spend the next 18 months A/B testing the bump conversion up 0.5% while ignoring that other 20%. But anyway, or you manually test. And this is where you pay someone to open 100 or 1,000 different pages in 8 different browsers and manually compare them, which is one of the largest wastes of human talent I've ever come across. Not only that, but midway through, the human brain just says screw it and shuts down, and the process is fairly error-prone. So most sensible companies will fall someplace in between. We'll pick the 10 or 15 landing pages that are most important, and we'll target the top 90 or 95% browser usage, and we'll check that the pages we care about look good in those browsers. We really should be doing this on every deploy, but that typically doesn't happen. But it's a difficult proposition. It's so expensive, but we've all experienced when that falls apart, how bad that is. You're embarrassed by it. It could cause loss of revenue. It's just a bad situation. So naturally, why don't we try to automate this? And this was a question I originally posed to myself maybe 5 years ago, but at the time I wasn't really ready to tackle it. And over the years, I've asked my web developer friends that are a little more in tune to this than me, why don't we automate it? And there seems to be this conventional wisdom now that if it were doable, it'd already be done, so therefore it mustn't be doable. Because why would anyone have the solution to this and not share it? So when you peel that away, say, well, why don't you think it's doable? And for a lot of people, it boils down to the way a page looks is a usability concern. It's an aesthetic thing. You can't test aesthetics. And that's true. CSS helps us define the styling for a page. But pages do have a logical structure to them. We have a header. We have a footer. We have a sidebar, content areas, comments. Some of us will take it to the next level, and we'll have semantic class names and IDs that call this out. Or we'll use the structural tags in HTML5. When you kind of look at it this way, what we have is a problem domain. And we have a language that defines data transformations. And what we get is a resulting output that we want to verify is correct. And when you look at it that way, it's really no different than any other type of automated testing. Yeah, it's a little more complicated because your domain's within a browser. The language isn't really a programming language. It's a descriptive one. And then when you actually want to test it, you need to use a real programming language. But if you manage to make that logical leap, then the remaining question is, all right, so why haven't we done this? And one of the biggest reasons is it's been traditionally very cost prohibitive. When I first started thinking about this 5 years ago, cloud computing hadn't quite taken off, and to get going was going to cost tens of thousands of dollars in equipment. Nowadays, these tests can be run for tens of dollars, and the trend is such that costs will continue to go down. So it's not as dismal as I've painted it. We have seen some work towards automating this. Particularly 2 years ago, Michael Tam gave a wonderful talk at GTAC in Zurich about his open source fighting layout bugs library. And what he was trying to do was provide a tool that worked like find bugs, where it would parse a page and handle a common set of rendering issues, such as low text contrast, or text that collided with div boundaries, content regions that overlapped. And this worked pretty well if you're willing to work within Java or the JVM. Incidentally, around that time, I decided I was going to take a stab at this. And Apparently, I'm not very good at research because I didn't know Michael was working on it at all. So I kind of went about it a different way, and the result of that is basically what I've been calling web consistency testing. And it complements Michael's work pretty well, and the two of them can be used in conjunction with each other. So web consistency testing is all about ensuring a consistent user experience, regardless of whatever browser or device they're on. More colloquially, it's about answering the question, does this page look right? This is an intentionally fuzzy definition, which is a little weird when you're trying to talk about automation. But pretty much any human can handle this pretty well, so that's really what I wanted to do. As a simple example, here's a page I looked at recently that has some news entries in a sidebar. These are two pretty modern browsers. We have Chrome and IE9. And the differences here are quite subtle. If you don't see them, some of the font weight's a little different. We have cases where text is wrapping around in weird places. But in isolation, looking at either of these pages in that browser, I wouldn't say either of them is wrong. As a matter of fact, I'm not actually sure which one's right. Traditionally, we've tried to strive for pixel-perfect design, and that's a fool's errand. Here, any effort to try to make these look exactly the same is just absolutely a waste. On the other hand, here's another example where a page looked at in Chrome and Firefox 6. I took these slides before Firefox 7 came out. Just glad 8 didn't come out before the talk. In this case, we have a form that wrapped around to the next line. And it's a bit jarring. I definitely would think something was wrong here. And as a web developer, I would want to know about that. In this particular case, the issue is fairly minor, but we've all encountered cases where a form element is wrapped or a div is wrapped, and it causes the rest of the page to end up completely out of whack. So what I really want is a function that models this process. We just looked at 2 pages, and we discovered there was a set of rendering issues. So that's where I started with this. I wanted to give some function 2 pages and get back a set of rendering issues. So the 2 inputs are page representations. One's a reference page. And this basically matches how many web developers go about doing development. They'll make sure a page works in whatever their pet browser is, and then every other browser gets compared against that. And then the differences get resolved. Since we're dealing primarily with how a page renders, there's really 2 ways that you'd represent a page. One is it is an image, which is basically how a user sees a page. And one is via DOM, which is basically how the browser generates the image that the user would see. So there is a logical equivalence here, but you have to do a little dance to make it work. Image representation is great if you're looking for pixel-perfect design. There's a lot of algorithms out there for comparing images. It's 100% browser independent. But some of the issues I've had with it is when you get a diff, what you see is a region of pixel differences. It lacks semantic meaning. It's definitely helpful, but when I'm looking at it, I don't necessarily know where to go start fixing things. In that first case where we were allowing things to shift, that becomes computationally much more expensive when you're doing image comparisons. And then if you have any sort of slide deck or slideshow, it quite easily confuses image comparison. Like in this example, we have what is essentially the same thing on the page, but one is rotating through and it's on page 2, one's on page 4. This would utterly confuse an image comparison. The DOM representation is actually a fair bit more complicated to capture, and you do have to do some data conditioning. But the benefit of the DOM is, with very few exceptions, everything can be represented as a rectangle in a 3-dimensional space. And we have very simple algorithms for determining where something sits in 3-dimensional space and distances between rectangles and all that. More importantly is when you're working with the DOM, when you detect an issue, you know exactly where you are in the DOM. You have rich semantic meaning about that. Your set of rendering issues that we'll report will tell you exactly where a problem occurs. The other beautiful thing about DOMs are their trees. Makes it very easy to traverse them. So when we do this data conditioning, for instance, we'll go through and we'll strip out any element that doesn't have an actual visual representation, like the head tag. We'll go through and normalize things like the opacity values. There's a lot of browser vendor extensions around this. Internet Explorer used to do it through their filtering mechanism. But what we really want to do is get the opacity value. So you can take a quick pass through this to do your normalization. And trees have a lot of wonderful algorithms about them on how to traverse them. For the purposes of web consistency testing, we're going to use a heuristic-based depth-first search. Really, you're limiting yourselves to either depth-first or breadth-first search because we have to do a completely exhaustive search. There's no opportunity to abandon search early, so looking to use one of the path-optimized search algorithms isn't really going to buy you a whole lot. For those who are unfamiliar with depth-first search, I just kind of threw up a quick annotation here, but basically you'll move down, starting at the left, all the way until you hit the end. When you do, you'll bump up a level, move right, and so forth and so on. As it turns out, depth-first search has some other interesting properties. The DOM naturally represents containment hierarchies. Some of this is enforced by HTML itself. LIs always appear in ULs. Some of it's just enforced by convention. Developers, if they want that UL to appear within something else, they tend to shove it in a div or what have you. So this is really interesting for something I'll get to in a moment. Likewise, a lot of developers will adopt this Western left-to-right mentality, which really is a way of saying that if something appears to the left of something else on a page, it probably appears higher in the DOM. So depth-first search allows us to take advantage of both those properties. And yeah, there are some really perverse things you can do with absolute positioning that would change this, but those are the exception rather than the rule. And it's fairly easy to isolate those and deal with them. All right, so when we compare the DOM, we're basically going to go through and just go element by element. And we're going to check where it exists on a page. And if there's an issue, it's pretty easy to tell. We'll operate with a tolerance threshold. And if, say, the left position between two divs is off by 200 pixels, and that exceeds the tolerance threshold, we can annotate that. As we're going through, we'll apply a few heuristics. Some of these were pretty annoying to figure out. Hindsight's 20/20, but for instance, anything with visibility hidden, you just don't even need to consider. Completely cut that out. If an element is occluded by another one, so you can't actually see it, it'll still sit in the DOM, but it doesn't matter where it's positioned because a user can't actually see it, so you can deal with that. That whole slideshow thing, that tripped up image comparison, it rears its head in DOM comparisons, but in a different way. In particular, the slideshow itself will appear in the same position, but each of those panels will have a different opacity value. So you'll just need to be aware of that and handle it. What's wonderful about web consistency testing is we really want to surface rendering issues, not rendering differences. So taking a look back at this page here, it's pretty obvious that the form is wrapped around, but the text field is also wrapped around. The submit button is wrapped around. If you were just doing a naive DOM comparison or doing an image comparison, each one of these things would be reported as a problem. But what's really the issue? I mean, when we look at it, the submit button and the input field are correct relative to each other. We want to report just the form as being the problem. So this is where the whole containment hierarchy portion of depth-first search works out for us. Because what we can do is we can calculate a SKEW. And when we do the sub-search and recurse here, we can push that SKEW down to the next level. And it'll allow us to effectively normalize the origin for the root node. And then we can start comparing from there as if there was never an issue to begin with. And what this allows us to do is if a page would have otherwise reported a couple hundred issues, there might only be a half dozen root issues, and we'll surface only those issues. There's a risk here that you'll miss a couple legitimate issues, but we'll never have a false positive. And once you fix these core issues, the other ones will be surfaced after. So this is more of a lather, rinse, repeat cycle, but the idea is you're never wasting time trying to track down something that isn't really an issue. So there are other considerations. Like I said, we have this notion of a tolerance threshold. If you're looking for pixel-perfect design, just set the tolerance threshold to 0. If you're OK with a couple things wrapping here or there, you can bump it up. Empirically, we've found that 30 pixels works pretty well. We've detected about 2 million issues across 500,000 pages. And for the most part, they've all been pretty good. One part that trips up this DOM comparison pretty hard is when there are DOM mismatches. So as I was saying, when you have the two trees and you traverse down, you're going to do an element-by-element comparison. If you're using one of these older versions of IE and have something like Dean Edwards' IE7 script in there, it's going to just inject things into the DOM. And you'll have to do a fuzzy match instead to deal with this. Or if you're comparing over time and the DOM changes subtly. As it turns out, just using the same rules that CSS uses for specificity, you usually do OK. Basically, you'll look at the element name, look at the set of classes, look at the ID, and then look at the hierarchy, rather than just looking at the position. And then there's a couple other concerns, but for instance, you'll want to be able to handle authentication or deal with pages that exist behind a firewall. So fairly minor things altogether. The results here are extremely developer-friendly. Like I said, what we're returning is a set of CSS selectors. We're giving the error dimension. Is it off in the vertical axis, the horizontal axis? Is the opacity value off? And we're going to return the error value. So showing a quick sample here. This was that page where the form was off. And the system was able to detect that the form, you can see the CSS select down here. Actually, the form elements were wrapped in a paragraph, and the paragraph is what was off. But by using that information, we can overlay it right on a set of screenshots here and visualize the error, which makes it really easy to figure out whether or not it's actually a problem. And then we can hand off this CSS selector to a developer and let them know, hey, this thing's off by 560 pixels. Here's another example. This is a typical contact form sitting in the footer of a page. It's off pretty substantially in the vertical axis. So in the original definition of the function, I said they were page representations. I was using cross-browser as a motivating example, but as it turns out, this approach is actually multidimensional, and it works pretty well. Basically, if you can take two different representations of a page, you can compare them the same way. So another really great example of this is doing regression. We've all been in that position where you're working on a page, you want to add 5 pixels to the right margin to fix a display bug, but that CSS file is linked to by 75 other pages, and you don't really know what the ramification of those changes are. If we take a snapshot of the page beforehand, and then we make the change and take a snapshot of all the pages afterwards, we can see whether there were any issues that were created as a result of that change. And if we maintain full copies of the code at each stage, we can even present a code diff and say, hey, you made this change, 3 of these pages broke, and by the way, it's extremely likely it was the result of one of these 3 lines of code that you changed. Taking a step further, you can even build up internal knowledge base about this. So when you fix the issue, you also have the diff. So now you know how to fix the problem. Should you ever break it again, you can look back and say, hey, the last time this broke, this is what we did to fix it. Another case where we can compare 2 different page representations is internationalization. So make the page look great in the language you're looking for. for many of us, I'm guessing that'll be English, and then run it through in a different locale and take a snapshot within the same browser at the same point in time, and you can do the comparison and figure out what elements are broken in each locale. Another case we've come across is just dealing with bandwidth constraints. Maybe you're targeting smartphones and you want to see what the difference is between Edge and 3G. Load up the page in both, wait 3 seconds, take a snapshot, and you can get a pretty good idea of what's going to break in that case. Another pretty interesting aspect of all this is there's no real programming required. I mean, don't get me wrong, building the system takes a lot of effort, but once you do, it's not tied to any particular application. It matches exactly how we develop pages. Views evolve quickly, and since we already have implicitly stated that if we develop in Chrome that the page looks good in Chrome, then that page implicitly encodes a set of rules about what we want to test against. So this whole process adapts as your application grows. You never have a risk of running with tests that are completely out of date. And it's just a really interesting way to go about it because anyone can enter a URL, which is another way of representing a page. So we can make testing available to those that don't know how to program. Everyone knows how to compare 2 pages. So if a marketing guy needs to launch a new campaign and wants to test his landing pages, give him something like this. He can test it through. And if there's a problem, he can give more information to a developer and a bug report than he'd ever be able to give otherwise to help them fix the problem. And again, like I said, there's no maintenance to the system required. I mean, you're going to run a grid, and there's maintenance with that. But there's never a case where you've all of a sudden decided you're going to change to a different web framework, or all of a sudden you're going to adopt CSS3, and all of your tests fail, because there is no test that you're writing. So in recap, web consistency testing is all about enabling a consistent user experience for your customers, regardless of whatever browser or device they're working on. We want to match or model the way developers typically approach web development, but we also want to model the way viewers typically take a look at a page. And this is all about not caring about minor issues, things that, simple text that wraps. You want to find actual legitimate issues. And when you find these issues, you want to be able to fix them as quickly as possible. So we want to provide intelligent results. And by doing this, we can take a process that used to be very expensive, take many hours, and make it very simple, something we can do as we develop, and basically move the entire state of web testing forward. So that's it. Thanks for your time.
We have time for questions. Raise your hand, we'll get you a mic.
So what kind of frameworks you use to compare it across browsers and across platforms?
We build a top Selenium grid, so that's how we drive our browsers. And then we use Selenium to basically drive the browser. And to capture the DOM, you kind of just take a serialized copy of the DOM. It's pretty straightforward to do in JavaScript. Once we have that back, we have a JSON representation of the DOM, so we can just feed it through a data analysis and do that whole heuristic-based depth-first search comparison I was talking about.
Is this like always a service, or is it open source, or what is it exactly?
And I run a company based on this,
okay.
But I'm trying to push forward a concept here of a new type of testing. I want to get us out of this rut of, let's be honest, most people never get past testing just the back end. Extremely few of us will ever test JavaScript on the front end, and I guess slightly more will do acceptance testing using something like Selenium. But none of us, on the whole, are really checking that a page looks the way it should. And as we continue to push things forward onto the web, and we have an explosive number of different browsers coming out. You know, there is some consolidation on how browsers deal with certain aspects of the specifications. It's not as bad as it was, say, 10 years ago, but at the same time, Chrome and Firefox in particular are coming out with rapid releases, and they're picking up different portions of the HTML5 and CSS3 specs. Smartphones are really taking off in the US right now, and that's adding a lot of different browsers. And it's just not scalable to manually continue testing the way we have been. And when you're faced with a tough problem where testing is difficult, I don't believe the solution is ever not to test. So that's why I'd like to see this get, you know, more widely adopted.
Thanks.
It sounded like your DOM testing heuristics were heavily dependent on the browsers that were generating the DOMs. Could you consolidate that with a claim that this is very low maintenance?
I don't think it's actually dependent on the browsers at all. A browser is going to have an internal representation of what the page is, and that's going to be an annotated DOM. We're going to have the element structure. We're going to have all the properties associated with that. Its left position, its offset, its width, its height. And that's going to continue to be true as long as we have HTML and CSS. Obviously, this falls apart in the case of like WebGL, where you have something that isn't DOM-based at all. So it's extremely adaptable to new sets of browsers. As long as you have a way of interacting with that browser to capture the DOM, then it doesn't really matter where it came from in order to work with this. So in that sense, yes, it's low maintenance. I mean, it's taken me 18 months to get as far as I have, and I'm trying to help people not get stuck in some of the same ruts I did. So I think you get going considerably faster now, and then once it's running, you know, you might run into a couple of edge cases, but for the most part, it should be fairly low maintenance. Does that answer?
Sure. I'm not very familiar with the degree of customizations browsers make, you know, custom extensions and how that affects this.
Okay. Yeah, it affects it really not that much at all. Where things get a little wonky is when you have invalid HTML, and then every browser kind of does something different. For instance, I ran into a case where a table row was just created, not in a table. As it turns out, IE will like create an anonymous element and shove the table row in that. Firefox did something completely different, and Chrome did something even different beyond that. So that was a case where I had to kind of just discover what happened there and add a new heuristic for that. But for the most part, the heuristics are pretty well defined. And I'm sorry, I don't actually have this site up yet, but my intention is, well, there's going to be video, and people will watch this many years from now. But my intention is to basically have an ontology of these types of heuristics where you can go through and have a community sharing this type of information.
Yeah, I was wondering about extremely dynamic content and its effect on where the DOM might actually shift based on content generation. So if you have a reference page, but that might actually shift over time.
Yeah, so everything's going to be point in time. If your page kicks off some JavaScript when it loads, and 3 seconds later it pulls in a whole bunch of stuff, then yeah, you'll have some timing-related issues for that. But on the other hand, it can adapt pretty well with things like you submit bad form data or you hover over an element, because those manipulations are going to be reflected at the DOM level as well. So you could combine this with some of the more traditional testing you do with something like Selenium, and now you can test error states as well, which is something I know very few people actually do. So submit some bad form data and see what happens. Do you get the correct error messages? Does the first form element that's off get highlighted? Things like that.
Hey, Kevin, this is Denali from Okta. I just want to say thank you so much for an excellent presentation with a lot of detail and explanation. I really appreciate it.
Oh, thank you.
But I'm wondering, can you kind of describe like your customers, your business model, like how you charge for this, stuff like that?
Sure. I was trying not to turn into a vendor pitch, but I'd be happy to
she asked
talk.
the question. Now you have to.
I mean, we do it as software as a service. We have to run against a grid of browsers, so selling it as kind of off-the-shelf software would be a non-starter for a lot of people, because now we're back to that expensive case where, yeah, you have cloud computing, but it's still pretty expensive to have a base set of browsers at the ready all the time for your testing. So we do it as software as a service. We're really trying to make it as simple to use as possible, so we can spider through a site. You don't have to enter all the URLs. We do have non-programmers using it as a form of acceptance testing. But at the same time, we do have an API available, so you can do things like integrate it with your CI server, or when an issue is detected, auto-file it in the JIRA or what have you.
Yeah, quick question. I don't know if you already covered it. How do you deal with pages that actually have dynamic, DOMs based on interaction, right? I mean, I was actually looking at your page, right? You hover, things show up. How do you deal with being able to tell if that renders correctly across,
yeah, I think this is similar to the question she had over there, where you can just, you can take a two-prong approach and integrate this with, your more traditional Selenium type testing or WebDriver, where you just hover over, and once you hover over the element, or you submit a form, or whatever interaction you want to perform, you can just snapshot the DOM at that point, and basically, then you can test your various states.
So how do you deal with ads? Do you have any ad detection system in the system?
I'm sorry.
How do you deal with ads? Like, because like the web has a lot of ads nowadays. So how do you deal with ads and dynamic content, which is constantly changing? So ads will always be different, right? If you load a CNN.com on Chrome, and if you don't load a CNN.com like 2 seconds later on Firefox, there will be different content because the ads.
Oh, ads.
Yes.
Ads. Okay, sorry. Yeah, I was trying to read this, and obviously they weren't following either. Well, this is where that whole tolerance threshold thing comes into play, and that was sorry, I meant to call that out in the talk, and I didn't. But if your ad basically sits in the same position, and almost every site does, it might shift the dimensions a little bit, but the result is going to be basically everything's kind of in the same place. So you set your tolerance threshold appropriately, and you won't have any problems come up as a result.
Hi. Have you considered using any other ways to sort of manage dynamic differences due to dynamic content, like masking or something like that? Just curious if you went down that road and then had problems with it or what.
One way that I've dealt with it in the past, and I still prefer doing it sometimes, is using the hash portion of the URL. And basically there'd be a listener in the JavaScript that when it sees it, it takes whatever action I'd like. And the reason I like doing that is when I'm setting up test plans, I can just put in the URLs and I have a much better idea of what's going on. And then I'm cutting out the overhead of using something like WebDriver to go hover over whatever.
But at some point, you can just throw it over to a human, right? I mean, if you try to automate everything, it's going to get confused. So do you have like some formal process where you just say, okay, I don't know whether this page is the same. It's failing whatever criteria I have. It looks different to me, but it's close enough that I'm not sure that you could just give it to a human and try it out?
Sure.
Because you had that page, you had that nice where you could compare one page to another.
Yeah,
so who gets that?
Well, this was actually taken straight out of MogoTest, so this I would show to our customers. But you do have the option of ignoring things. So if it comes up and it might be legitimately a difference, but you just don't care about it, then you can mark it as ignored, and then you won't get alerted to that again.
It seems like it might be a good use of just crowdsourcing, right?
Let
a human look at it and
use a Mechanical Turk or something.
Yeah, right. Okay, thank you very much, Kevin.
All right, thank you.